Inverse functions, cubic, cube root. Not all cubic functions have inverses. Many don't have nice inverses, some have nearly impossible inverses. In general, a cubic function doubles back on itself. So there is almost always a significant interval of the range for which the cubic function is not one-to-one, and there is no nice branching tool for it. But if you look at the basic cubic function, f of x is something times x cubed. This function exhibits fairly simple behavior and is one-to-one. Likewise, the basic form of the cube root function gives you one-to-one behavior. So if you have a cubic or cube root and not too much in the way of further complication, you can find the inverse function without having to worry about restricted domains or anything like that that you have in the quadratic and square root cases. So let's look at a particular function. F of x is 6 minus x cubed. Again, because this is a cubic function, we have that nice cubic sitting by itself. There's a constant thrown in to make things a little bit messy, but you don't have an x squared or an x term added into the confusion. Because of that, we know that this is going to be a one-to-one function. If we had those things, we would have to graph first and check to see if we had a one-to-one function before we started in. But I know that this is going to be one-to-one, so I can simply swap my x and y variables and solve for y to find an expression for the inverse function. I'll subtract 6 from both sides of the equation, and then because I have that negative there with the y cubed still, I'll multiply both sides of the equation by -1, which changes the order of subtraction. Then to get y by itself, I'll take the cube root to get this expression. My inverse function is simply the cube root of 6 minus x. Compared to the quadratic and square root cases, the cube root functions are quite a bit more straightforward.